If you clicked on this video hoping to see Keanu Reeves and Lawrence Fishburne running around doing kung fu, I have disappointing news for you. You clicked on the wrong thing. But stick around because you're going to learn something almost as cool and exciting, and that's adding two matrices. First things first, in order for you to add matrices, you have to make sure that these guys are the same exact type of matrix. A matrix is basically a little box, holds all these elements, their numbers, and this has 3 rows, 2 columns. So we would call this a 3 by 2. This has 3 rows, 2 columns, so this is a 3 by 2, which means yes, you can add or subtract these matrices together. When you do that, you look at every operation that you need to perform in every section. For example, first row, first column is a 3, and you're going to add 0 in the first row, first column. So you become 3 plus 0. Okay, you are 6 plus -1. You are going to be -1 plus 6. You are going to be -3 plus 0. You are going to be -5 plus 2. And you are going to be 3 plus, no, -1 plus 3. I don't know why I did that. -1 plus 3. And so basically when you do all that and simplify every part, you're going to get a 3 by 2. 3 plus 0 is 3. 6 plus -1 is 5. -1 plus 6 is 5. -3 plus 0 is -3. -5 plus 2 is -3. And -1 plus 3 is 2. So did I use a bit too much? Did I take too much time on this? Yeah, because you could just be like 3 plus 0 is 3 and 6 minus 1 is 5. And you're absolutely right. But I showed my steps, so it worked for me. I know Kung Fu. Oh, thanks for watching. Simplify -5 times this matrix. This process is called scalar multiplication. You have yourself a nice matrix. It's a, what is that, a 2 by 3. You got 6 elements living in here and a -5 being multiplied to it. So if you've never seen this before and you're thinking, is this just distributive property and multiply -5 to all 6 of these guys? You're 1,000% correct. Multiply -5 to all of them. So 5 becomes -25. -5 times 6 is -30. -5 times -4 is +20. -5 times 4 is -20. -5 times -2 is +10. -5 times -1 is 5. We end up with a matrix, same exact amount of elements, but -5 is multiplied to all of these. So again, this is called scalar multiplication of a matrix. I know Kung Fu. Oh, man, that joke will never get old. The Matrix, remember them? Thanks for watching. Simplify this matrix plus that other matrix. Well, what we have here is not only just numbers, but letters and variables too. And although it doesn't look like it, these are connected in the same exact matrix. We have 1, 2, 3 rows of 1 column. So this is a 4 by 1, and this is a 4 by 1. So by the letter of the law, we can combine these. Now, showing all of our steps and showing all of our work, if we add a 4 by 1 to a 4 by 1, we're going to get a 4 by 1, right? And the first column, first row, first column, well, only column, but the first row is going to be me adding this to that. So z minus 5 plus -3y. Now, we'll clean that up in a little bit, but, you know, time is money. -6 plus 3z, so -6 plus 3z. -1 minus 6 plus 5 plus z. No, -1 minus 6z plus 5 plus z. So -1 minus 6z plus 5 plus z. And then we have ourselves in purple 3y plus 4z. So I guess the idea of this problem that I stole from the internet, I tried to make you purple, but you're not purple, you're green. Doesn't matter if you're colorblind, you can't tell anyway. So what we're going to do is we're going to look at each. I'm sorry if I offended any of my viewers that are colorblind, but this will be my 18th colorblind joke, so this shouldn't be anything new to you. What you're supposed to do is combine like terms. Well, in the case of this first row, there's no like terms to combine. You just end up with z minus 5 plus negative means minus 3y. Nothing happens there. Combine like terms. There, again, is nothing to combine. This problem is stupid. But finally, we end up with something we can combine. We have negative 1 plus 5 is 4, regular 4. And you have negative 6z plus z is minus 5z. So those do combine. 3y plus 4z, nerfing. So that's what you end up with. You end up with a matrix with a bunch of variables and non-variables, and it's a mess. But that's how we simplify when we add two matrices that are the same exact row column format, and you're trying to combine like terms some of the time. Fun stuff. Simplify a 2 by 2 matrix minus a 2 by 2 matrix minus a 2 by 2 matrix. Now, when you are subtracting or adding matrices, you must make sure that they're all the same exact columns and rows, which they are all as well. Now, what we're going to do is we're going to subtract these two matrices together and then kind of have that linger and then subtract it again. When you subtract matrices, you are subtracting the elements in the same row column, in the same position. For example, U would be 5 minus negative 6. 5 minus negative 6 is 5 plus 6, which is 11. Okay, let's do it again. 3 minus 0 is 3. Nothing to overthink there. 5 minus 1 is 4. Nothing to overthink there. And 1 minus negative 4 is 1 plus positive 4, which is 5. So these first two matrices become 11, 3, 4, and 5. Now we're going to bring this guy down and do the same exact thing. So minus 5, 4, negative 2, negative 6. Do it again. 2 by 2 minus a 2 by 2. Everybody should be just fine. Everybody should be just fine. Let's do it again. We have 11 minus 5, which is 6. 11 minus 5, which is 6. We have 3 minus 4, which is negative 1. We have 4 minus negative 2. 4 minus negative 2 is 4 plus positive 2, so that's a 6 again. And then last but not least, 5 minus negative 6. 5 minus negative 6 is 5 plus positive 6. That becomes 11. So when all is said and done, u minus u becomes 6, negative 1, 6, 11. We have subtracted matrices, and we had a great time doing it. And doesn't that look pretty? Now we are multiplying matrices. This is where things get a little nutty, but that's all right. I'm here to help you out. What you have to do is you have to find the dimensions of each matrix before you could even consider whether or not you can multiply these guys. You have 2 rows, 2 columns, you're at 2 by 2. You have 2 rows, 2 columns, you're at 2 by 2. Now, just because they have the same exact dimensions doesn't always mean you can multiply them together. What you have to do is you have to make sure that the number of columns of the first matrix matches the number of rows of the second matrix. Make sure these two guys are the same exact number, and they are. When you do that, your resultant matrix is going to be the two outside numbers. So we are going to end up with a 2 by 2 matrix here. So let's kind of write this out, give ourselves plenty of space. You will see why. We will end up with a 2 by 2 matrix, so I'm using dashed lines to show that we have 2 columns, 2 rows. There you go. Now, when you multiply matrices, this is what you do. You take the first row, and you take that first row and split them up by rows. So we're going to split you up by your rows. We're going to take the second matrix and split that up by columns. All right, so watch what I do. Be very careful. The first row, first column in our resultant matrix is going to be the result of taking the first element of this row and multiplying it to the first element of that column. So negative 5 times negative 2 is positive 10. Then we do it with the second guy. The second element of this row and the second element of this column. Negative 5 times regular 3 is negative 15. And we take those numbers and we add them up. Okay, so if you wanted to put plus signs right here and get that out of your way, sure, be my guest. We do it again. Okay, we do it again. So this is the first row, second column. So we're going to focus on the first row, second column again. Negative 5 times negative 3 is going to be 15 positive. Negative 5 times positive 5 is going to be negative 25. We'll clean that up when we have to. Do it again. Okay, now we're on the second row, first column. So second row is negative 1. Multiply that to the first column, negative 2. And negative 1 times negative 2 is positive 2. Do it again. Okay, second row, first column. So the second element in each is going to be 2 times 3, which is 6. We'll clean that up when we have to. Okay, let's wrap this guy up. Okay, second row, second column, negative 1 in the first row. Second row, negative 3 in the second column is going to be positive 3. Negative 1, negative 3, positive 3. 2 times 5 is 10. Now we clean this up. 10 plus negative 15 is 10 minus 15, which is negative 5. 15 plus negative 25 is 15 minus 25, so negative 10. 2 plus 6 is 8. 3 plus 10 is 13. That's our guy. So multiplying matrices is definitely a busier process than adding them. But we did it, and boy did we have fun. Solve me multiplying these two matrices together. In order for you to multiply two matrices together, you need to find the dimension of the first matrix and the dimension of the second matrix. You have 2 rows, 3 columns, you're a 2 by 3. You have 3 rows and 2 columns, you're a 3 by 2. Now, what you need to do is determine whether or not you can actually multiply these guys together. And so you try to make sure that the number of columns in the first matrix matches the number of rows in the second matrix, and they do. Since they do, your resultant matrix is going to be a 2 by 2. So let's create a 2 by 2. Let's get some dash lines going on here, some dash lines going on here, because we're going to do quite a bit of math. In order for you to multiply two matrices together, you take the first matrix and you split that up by its rows, and you take the second matrix and you split that up by its columns, like so. And then you take turns multiplying the numbers in each particular area, corresponding area, together, and then adding their products. So in other words, this is the first row, first column. So first row, first column is going to involve me going to the first row, first column, and multiplying the first elements in each together. 5 times negative 4 is negative 20 plus sign. Then do it again. Second element, second element. 3 times negative 3 is negative 9 plus sign. Third element, 5 times 3 is 15. Bingo, bango, bongo. That was the first row, first column. Now let's do first row, second column. So we're going to focus on the same 5, 3, 5, but now we're going to also focus on 2, 4, negative 5 because that's the second column. So first element, 5 times first element, 2 is 10 plus sign. Second element, 3 times second element, 4 is 12 plus sign. Third element, 5 times third element, negative 5 is negative 25. Okay, first row complete. On to the second row, first column. Second row, first column. First element times first element is 1 times negative 4, which is negative 4, plus sign. Second element times second element is 5 times negative 3, which is negative 15, plus sign. 0 times 3 is 0. Okay, third element multiplied together. Let's close this bad boy up. We've got 1, the second row, second column. First element is 1 times first element, which is 2, and we get 2 plus sign. 5 times 4, the second element is 20, and then 0 times negative 5 is just going to be 0. Now we take each corresponding part, okay, the top left, the top right, the bottom left, the bottom right, we do whatever addition that we have to do. Negative 20 plus negative 9 is negative 29. Negative 29 plus 15 is negative 14. So first row, first column, negative 14. 10 plus 12 is 22, the Taylor Swift special. 22 plus negative 25 is negative 3, top right. Negative 4 plus negative 15 plus 0 is going to be negative 19. And finally, 2 plus 20 plus 0 is, again, the Taylor Swift special. I don't know about you, but I'm feeling that this number is 22. Everything will be all, I'm done. Thanks for watching. Love you all. Let's simplify this matrix times that matrix. Now, before we proceed, we have to figure out, can we even do this? What we do is we find the dimensions of each matrix. So you have 1, 2, 3, 4 rows, 1, 2 columns. So that's a 4 by 2. And you have 1, 2 rows, 1, 2, 3 columns. You're a 2 by 3, which means these two numbers in the middle match up, and we're going to end up with a 4 by 3. So lots of work to do. Lots of work to do. 4 by 3. So that's, let's split things up. Those are my 1, 2, 3, 4 rows. And I'm going to have 1, 2, 3 columns. In order to make this happen, we need to take our first matrix and split them up by their rows. Take our second matrix and split them up by their columns. All right. We have, in each part, we're going to have the 2 elements plus 2 elements. So if you want to get this out of the way, you could just throw plus signs in front of each of them. When you multiply matrices, you're going to multiply the elements and then add all of the products up. So why don't I just throw those plus signs in there, get them out of the way, and that'll kind of help me keep things nice and level and stuff like that. All right, here we go. You ready? It's going to take a couple minutes. First row, first column. First row, first column. Negative 2 times 2 is negative 4. Negative 6 times negative 2 is positive 12. There you have it. Okay. First row, second column. First row, second column. Negative 2 times negative 2 is positive 4. Negative 6 times 0 is 0. Let's do first row, third column. First row, third column. Negative 2 times 2 is negative 4. Negative 6 times negative 3 is positive 18. So many colors. All right. Second row, first column. Negative 4 times 2 is negative 8. 3 times negative 2 is negative 6. Second row, second column. Second row, second column. Negative 4 times negative 2 is 8. 3 times 0 is 0. Second row, third column. Second row, third column. Negative 4 times 2 is negative 8. 3 times negative 3, negative 9. Third row, first column. Third row, first column. 5 times 2 is 10. 0 times negative 2 is 0. Third row, second column. Third row, second column. 5 times negative 2 is negative 10. 0 times 0 is 0. Third row, third column. Third row, third column. 5 times 2 is 10. 0 times negative 3 is 0. Let's wrap this guy up. We've got a fourth row, first column. Fourth row, first column. 4 times 2 is 8. Negative 6 times negative 2 is positive 12. Fourth row, second column. Fourth row, second column. 4 times negative 2 is negative 8. Negative 6 times 0 is 0. Last time I checked. Let's wrap this guy up. We're almost done. Almost made it. Almost home. Okay. Last row, last column. 4 times 2 is 8. Negative 6 times negative 3 is 18. Now let's do 12 separate addition problems and be done with it. Negative 4 plus 12 is 8. 4 plus 0 is 4. Negative 4 plus 18 is 14. Negative 8 plus negative 16 is negative 14. 8 plus 0 is 8. Negative 8 plus negative 9 is negative 17. 10 plus 0 is 10. Negative 10 plus 0 is negative 10. 10 plus 0 is 10. 8 plus 12 is 20. Negative 8 plus 0 is negative 8. 8 plus 18 is 26. And we're done. Holy cow. Multiply this 2 by 2 to a 2 by 2 and then subtract a 2 by 2. Well, the nice thing about multiplying two 2 by 2s is you're allowed to do it, and you're going to get a 2 by 2 in the end. So this will become this, but it's going to be pretty sloppy. So let's split this up. Like I said, you're going to get a 2 by 2 in the end. There you have it. We're going to take the first matrix. We're going to split that by rows. We're going to take the second matrix, split it by columns. And remember, you multiply the first element in each row-column combination, then add you multiplying the second element. So if we want to, since we're only doing something times something and something times something, we could just throw those plus signs in the middle, get that out of the way right now, because why the heck not? So 6y times negative y is negative 6y squared. Y squared and negative 6 is negative 6y squared. So those will combine at some point. We've got first row, second column, so 6y and xy becomes 6xy squared. And then y squared and x squared becomes x squared, y squared, I guess if we're keeping with alphabetical order. Okay. Doing great, doing great. Second row, first column, negative 2y, negative y, positive 2y squared. And then we got negative 2y, negative 6, positive 12y. And then last but not least, we've got ourselves the second row, second column. So that's going to be negative 2y, xy, so negative 2xy squared. And then negative 2y, x squared is going to be negative 2xy. No, x squared y. Ooh, that was a close one. Now, we're going to still subtract u once we get there, but we're not there yet because we have some simplifying that we can take care of right now. All right, so let's simplify. Lots of combining like terms. Negative 6y squared plus negative 6y squared is negative 12y squared. 6xy squared plus x squared y squared doesn't combine, so this ends up being 6xy squared plus x squared y squared. These guys don't combine, so 2y squared plus 12y. And these guys don't combine, so negative 2xy squared minus 2x squared y. And after all of that, we still have this matrix floating around. Now we are subtracting a 2 by 2 minus a 2 by 2, which is perfectly allowable. And what we'll get is we'll get at 2 by 2. Right? So you're the first element. So negative 12y squared minus 6y has no combining. So negative 12y squared minus 6y just ends up being that. All right. We've got 6x squared y squared plus x squared y squared plus, or I'm sorry, minus negative 6. So it's going to be, let's get this part out of the way, 6x squared y plus 6x squared y squared minus negative 6 minus negative 6 plus 6. Okay, two more. 2y squared plus 12y minus 3y. So 2y squared is 2y squared. Plus 12y minus negative 3y is plus 15y, because minus negative is plus a positive. So 12y plus 3y is 15y. Why? Because I said so. And then we've got negative 2xy squared minus 2x squared y minus y. Nothing happens there. Pretty gross stuff, but we did it. Evaluate the determinant of this 2 by 2 matrix. The determinant of a 2 by 2 matrix is you labeling A, B, C, and D and finding out what A, D minus B, C is. So A is negative 5, D is positive 2, minus B is 3, C is 4, and it's just a little PEMDAS problem. Negative 5 times positive 2 is negative 10, minus 3 times 4 is 12. You become negative 22. The Taylor Swift special, but the anti-Taylor Swift special. The anti-hero. Oh, how fun is that? It all comes around with Taylor Swift. Evaluate the determinant of a 3 by 3 matrix. Let's write out a 3 by 3 in its letter form to make life easy for us. G-H-I. All right. This is going to be weird, so bear with me. What you're going to do to find the determinant of a matrix is you're going to take the first column and then the second column and then the third column. And whatever column you are not focusing on or you are focusing on, you're going to focus on the 2 by 2 diagonal determinant. I know that sounds weird. Bear with me. The first part is going to be A times the determinant of that matrix right there. So A times EI minus FH. Let's focus on that middle column, the B here, and we're going to come up with the determinant of a matrix that consists of DF, GI. All right. Oh, and here's the tricky thing. Minus. Weird. It has to make things super complicated. So B times the determinant of DF, GI, which would be DI, minus FG. Now, we'll add again. Okay, we'll plus again. C, and then we're going to focus on the determinant of that matrix right there. DEGH is going to be DH minus EG. Okay, so let's go over here and label everything. A, B, C, D, F, G, H, I. So the determinant of that is going to be 6, because that's our A, times E times I. So E times I is 4 times 5. So we'll just do that and write it all out. Minus FH. So minus negative 2, negative 4. Minus B, which is minus 5, times the quantity DI. So negative 5 times 5. Minus FG, which is going to be negative 2 times 1. And then plus C, which is negative 3, times the quantity DH. So that's going to be negative 5 times negative 4. Minus EG, which is 4 times 1. Okay, so PEMDAS. 20, negative, negative, negative is a minus 8. Minus 5. Negative 5 times regular 5 is negative 25. Negative, negative, positive, so plus 2 times 1 is 2. Minus 3, because plus negative 3 is just minus 3. Negative 5 times negative 4 is positive 20. Negative 4 times 1 is minus 4. Okay. 20 minus 8 is 12. Minus 5. Negative 25 plus 2 is negative 23. Minus 3 times 20 minus 4 is 16. 6 times 12, I believe, is 72. Minus 5 times negative 23 is plus 115. And then 3 times 16 is minus 48. So we've got 72 plus 115 minus 48. It's going to be 149. So that's your determinant. Fun stuff. State if the inverse exists. Well, the inverse of a 2 by 2 is going to be 1 over the determinant of whatever this matrix is times swap the D and the A, okay, and then make U negative and make U negative. Now, all I really care about is if that determinant is 0. Okay, the determinant exists, I'm sorry, the inverse exists if the determinant is not 0, because if it was 0, well, then you would have an issue, and that issue is having an undefined number. So the determinant of a 2 by 2 matrix in the form ABCD is going to be AD minus BC. So in our case, it's going to be 4 times 6 minus BC is negative 5 times negative 9. So this has a lot of promise because 4 times 6 is 24. Okay, negative, negative, negative is a negative. And 4 times 5 is 45. 24 minus 45 is negative 21. And since this is not 0, does the inverse exist? Yay, it does. Isn't that fun? Find the inverse of the matrix. Well, the inverse of a 2 by 2 matrix in the form A, B, C, D is 1 over the determinant. The determinant of a 2 by 2 matrix is AD minus BC. Then you take that fraction, whatever it is, multiply it to the 2 by 2 where you swap your A and your D. You make the B negative and you make the C negative. All right, so let's plug all this stuff in. 1 over A times D is negative 6 times 7. Minus B times C is 11 times negative 4. And that's going to be multiplied to the matrix where you swap the A and the D. So 7 goes here and negative 6 goes there. B becomes negative, so negative 11. And C becomes negative, so negative 4, positive 4. Negative 6 times 7 is negative 42. Minus 11 times negative 4 is going to be plus 44. And that's still going to be multiplied to 7, negative 11, 4, negative 6. Negative 42 plus 44 is 1 over 2. So we're going to do scalar multiplication and multiply a half to all of these. So we're going to get a fraction here and there. Half of a 7 is 7 over 2. Half of negative 11 is negative 11 over 2. Half of 4 is 2. Half of negative 6 is negative 3. And that is our inverse, baby. Solve this matrix equation. What we have here is a matrix equals 5 times B. And if you're thinking, well, let's just get rid of 5 and B will be all by itself, you're absolutely right. If you're thinking, let's divide both sides by 5, you're on the right track, but technically, you're not allowed to divide a matrix by a number. But what we can do is we can multiply both sides by its reciprocal. And yes, I'm squeezing that in on the left because it looks better. Okay, the order for matrices really matters. So if I'm going to get rid of the 5, I'm going to multiply the left side of 5 to get rid of it, which makes the scalar multiplication look a lot better. Now B will be all by itself on the right. This is scalar multiplication. 1/5 times negative 5 is negative 1. 1/5 times regular 5 is 1. 1/5 times negative 20 is negative 4. And you're done. Solve this matrix equation. Now, whenever you have a matrix equation, if you're not multiplying two matrices together, which we're clearly not, you're going to treat it like a regular old two-step equation. For example, if that was like 5, we would just subtract 5 from both sides. Well, why change the rules? Let's just subtract that entire matrix. So let's subtract 3, negative 5, 0, negative 2 from both sides. Subtract negative 3, negative 5, 0, negative 2. That will cross out and leave us with 4x on the right. Negative 5 minus 3 is going to, by the way, we're allowed to do this. 2 by 2 minus a 2 by 2 is a 2 by 2. Negative 5 minus 3 is negative 8. 31 minus negative 5 is 31 plus positive 5, which is 36. 32 minus 0 is 32. And 30 minus negative 2 is 30 plus positive 2, which is 32. Okay? Now, in order to get x all by itself, we have to get rid of the 4. Don't divide by 4 because you're technically not allowed to divide a matrix by a number, but what you can do is multiply both sides by its reciprocal. So I'm going to multiply it on the left so these guys are next to each other and cancel each other out. And since the order of matrices matters, we're going to multiply that guy on the left side too. Now it's just a regular scalar multiplication problem. We're going to take 1/4 of every number here. 1/4 of negative 8 is negative 2. 1/4 of 36 is 9. 1/4 of 32 is 8. 1/4 of 32 is 8. And we are dunzo, funzo, funzo, dunzo, funzo. We're done. All right, so we are asked to solve this matrix equation right here. And fortunately, we're not multiplying two matrices together. So you're going to treat this like it's a regular old equation, like negative 4a minus 5. What would you do? Well, let's add 5 to both sides. Well, we're not adding 5. We're adding that matrix. So the idea is the same. It's just we have to add 6 numbers instead of 1. So we're going to add negative 3, 5, negative 7, negative 1, 2, and negative 2 to both sides. Add negative 3, 5, negative 7, negative 1, 2, and negative 2 to both sides. Cross a U out. Drop down the negative 4a. And now we're going to do a little bit of adding, like, a little bit, like 6 of them. 31 minus 5 is 26. Negative 17 plus 5 is negative 12. 3 plus negative 7 is negative 4. 5 plus negative 1 is 4. 30 plus 2 is 32. Negative 30 minus 2 is negative 32. Now, you're not really supposed to divide a matrix by negative 4, so what we're going to do is we're going to multiply both sides by negative 1/4, the reciprocal, if you will. And so now the rest of this problem is just scalar multiplication. You divide everything by negative 4, multiply by negative 1/4. Same exact thing, same exact thing. What will that be? That'll be 6.5. Negative 6.5. You'll become 3. You'll become 1. You'll become negative 1. You'll become negative 8. And you'll become positive 8. All right. So yeah, not so bad. Not so bad at all, as the one song says. Solve a matrix times z equals negative 120. So this is basically a problem in this format here. If my job is to take a matrix times x, and that's equal a matrix, the way you solve this is you use a little rule where you take the inverse of the a to both sides, right? And then you multiply the to b in that order. All right, so what I need to do is, if I were to label you A, what I need to do is I need to find the inverse of A, and then in this order, multiply that to B. So the inverse of A is going to equal 1 over the determinant. So if I were to call you little a, little b, little c, little d, that would be 1 over AD minus BC times the matrix, flip-flop the A and the D, and then make the negative C and negative B, but not in that order. Do all that. So the inverse of A is going to be me doing, I'll just put another matrix there, that would be wacky. That would be doing 1 over 2 times 5 minus negative 3 times negative 5, like so, times the matrix, 5 and 2 flip-flop, crisscross. You become positive, you become negative, positive, just joking, positive again. All right, so let's figure this out. 1 over 10 minus 15. Ugh, that's not going to be fun. 5, 3, 5, 2. Okay, so that would be 1 over negative 5, so negative 1/5, scalar multiplication. The 5 is fine, the 3 is not fine, the 5 is fine, the 2 is not fine. So multiplying everything by negative 1/5 is going to give me the matrix negative 1, negative 3/5, negative 1 again, negative 2/5. All right, so that's A inverse now. So if we're going to use this format right here, and I'm solving for, in this case, z, not x, but you get the idea. Z is going to equal the A inverse, so this matrix right here, negative 1, negative 3/5, negative 1, negative 2/5, times the matrix negative 1, 20. Now what we're doing is we are multiplying a 2 by 2 to a, oh no way. Oh no, this will work. I thought it wouldn't work. To a 2 by 1. So we're allowed to do this, and we're going to get a 2 by 1, 2 by 1 in response. So 2 by 1, I can handle that. Split U up by a row. You're already split up by the one column that you are. First element times the first element is going to be negative 1 times negative 1, which is positive 1. Second element times the second element is going to be negative 3/5 times 20, so negative 12. So plus negative 12. Okay, plus negative 12. This guy, let's use a different color, is going to be negative 1 times negative 1, which is positive 1 again. Negative 2/5 times negative 20 is going to be plus negative 8. So finalizing this matrix and getting my answer is going to be 1 minus 12, which is negative 11, and 1 minus 8, which is negative 7. So that matrix times negative 11, negative 7 would give me that matrix. Isn't that neat? It is neat. Tons of fun. Let's solve a matrix times a matrix equals a matrix. Whenever you have a matrix times a matrix equals a matrix, you are going to use the format where your answer, your solution, is going to be, and we'll call you A and we'll call you C. If I give you something like A, B equals C, and your job is to solve for, in this case, B, you are going to come up with B equals, take the inverse of the left of each, well, not of each, but of A, that crosses out, and B is going to equal A inverse C. So this is going to be kind of unpleasant, but that's what we have to do. We have to first find the inverse of A. Once we do, multiply it to C. So it's not as simple as like, let's divide stuff from both sides. Wouldn't that be great? Well, it's not. So the A inverse, okay? Generally speaking, when you have the inverse of a 2 by 2, let's label U, A, B, C, D all in lowercase. It's 1 over the determinant, so A, D minus B, C. And then you're going to multiply it to where you flip-flop the A and the D, so you're a D now and you're an A. And you opposite the B and C, so negative B, negative C. Okay, so that's the inverse of a 2 by 2. Label yourself A, B, C, D. 1 over AD minus BC, D, opposite of B, opposite of C, A. Okay, so let's plug stuff in. 1 over negative 1 times 9 minus negative 2 times 2. Oh, this is not going to be fun at all. Multiply that to flip-flop the A and the D, so 9 and negative 1 make you positive 2, make you negative 2. All right. So 1 over negative 9 plus, actually this won't be so bad because the fact that it's a plus 4 and it'll make it 5, that won't be too bad. So that's going to be, times the matrix, ignore that little mark over there, 9 to negative 2, negative 1. So that's going to be negative 1/5 times the matrix 9 to negative 2, negative 1. And so when all is said and done, A inverse is going to be negative 1/5 times all of that. So yeah, we got some fractions, not the easiest stuff in the world. Negative 9 over 5, negative 2 over 5, positive 2 over 5. Ugh. None of these had to be nice, did it? And positive 1 over 5. All right. So that's A inverse. What I could do, since everything's kind of where it needs to be, is I'll just take A inverse and multiply it to C. So here's C. Okay. Here is C, negative 3, negative 5, 13, 21, 0, and negative 36. We have ourselves a 2 by 2 being multiplied to a 2 by 3, which is perfectly legal. So at the end of the day, we'll get a 2 by 3. So let's give that all the space we can. 2 rows, 3 columns. You're going to split U up by rows, split U up by columns, and now it's just matrix multiplication with a lot of fractions. So I'm not happy about that. Since I'm just doing an element times an element plus an element times an element, why don't I throw the plus signs there already, kind of get that out of the way so it's nice and clean and I don't have to do too much thinking and just have to plug the numbers in. And it's just a matter of, element times element, element times element. So first row, first column, negative 9 over 5 times negative 3 is going to be positive 27 over 5. And negative 2 over 5 times 21 is going to be negative 42 over 5. Hopefully things simplify. And if not, they don't. All right, let's do it again. Negative 9 over 5 times negative 5. Oh, okay, so 9. I can handle that. And negative 2 over 5 times 0 is 0. That's nice. That's nice. That's nice. Isn't that precious? All right. Negative 9 over 5 times 13 is going to be negative 117 over 5. Yep. So negative 117 over 5. Oof, don't like that. And then negative 2 over 5 times negative 36 over 5 is going to be positive 72 over 5. Gross. Yuck. All right, row 1's done. Let's get to row 2. 2/5 times negative 3 is going to be negative 6/5. 1/5 times 21 is going to be 21 over 5. All right. 2/5 times negative 5 is going to be negative 2. And then 1/5 times 0 is 0. And then let's round this guy out. We've got 2/5 times 13 is going to be 26 over 5. And then we've got 1/5 times negative 36 is negative 36 over 5. So probably some cleaning up, combining, simplifying. We'll take it from there. 27 minus 42 all over 5 is going to be negative 15 over 5. So that'll simplify. 9 plus 0 is 9. Negative 17 plus 72. What is that? Negative 45 over 5. Yep. So negative 45 over 5. That'll simplify nicely. 15 over 5, negative 2, and just making sure I did my math right. You never know. Oh, that's 26. Oh, please, negative 10 over 5. Why am I overthinking that? So this does clean up pretty nicely. Okay, so B, after all of this, B will end up being negative 3, 9, negative 9, 3, negative 2, negative 2. Okay, matrices, fun.